correct me if I'm wrong, you are talking about sustainable practices.
Yes.
Yes. So sustainability is great, Patrik, but if the shirt falls apart, it's a fail. What performance advantages like durability or color retention are actually winning over the skeptics?
Yeah, it's a great question. It's funny, one of the opportunities, and I didn't realize this at first, so this is actually something that we've learned along the way, but it was, I guess, when we went into this, and the reason I was excited about this was, of course, to try to help the industry move to the next phase.
Welcome to the show. Today, we are diving into the future of what we wear. Our guest is a titan of the apparel industry who has transitioned from leading global brands like Under Armour and the Aldo Group to tackling one of the biggest challenges on the planet, textile waste. Patrik is now the CEO of Reju, a company backed by the engineering might of Technip Energies. They aren't just recycling, they are regenerating polyester at a scale that sounds like science fiction.
Mm-hmm.
Patrik, welcome to the session.
Thank you very much. Happy to be here.
So, Reju talks about a world where North Star. So, was there a specific turning point when you realized this couldn't just stay a pilot project and had to go fully industrial?
Yeah, I think this moment in time for me was a very specific time, actually. I was working at Aldo as the CEO back in 2015, 2016. And in one morning, actually in the January 2016, I woke up and I realized suddenly that we had reached kind of an end of the runway, if you like. I was at the time doing a lot of restructuring. We were closing a lot of stores. We were, rethinking our footprint. And I realized that there weren't going to be very many shopping malls in North America that was going to be opened in the future. And, my whole career over 35 years had been on growth. It has been geographical growth. It had been retail growth. It had involved everything from mail order then to e-commerce and what have you. And then ultimately I saw that, the end of that opportunity was very much happening. At the same time, as I then moved on and started to work with Under Armour and building on that with all of the other brands that I'd worked with, the North Face, Vans, Reef, and what have you, I started to really realize the compounded effect that the industry was facing as it related to, the waste aspect of things. And of course, when you run these very large organizations and companies, there is a generation of waste naturally in the system. It's impossible to be 100% efficient, right? And the larger the company, the more challenging the problem. So for me, this journey in terms of truly realizing the problem started in 2016 and then continued to build all the way till the time I left Under Armour and joined Reju at the end of 2022, early 2023.
Okay, yeah. So that's great, yeah. So Rochester, New York, that isn't a random dot on the map. So what made it the perfect launchpad for Reju's first US industrial size regeneration hub? And how does it fit into your global game plan?
Yeah, we have done a tremendous amount of work, of course, to make sure that we understand, first of all, the problem. How big is this problem, and how will it grow going forward, and ultimately, how do you deal with it? One path could, of course, be to move everything to Asia, which has been the tendency, and actually deal with things over there. But what we saw early in our research was the fact that the problem actually in terms of post-consumer textile waste, and remember, that's what we're focused on, is the waste that's being created at the end of life, right? Which is in the market. This waste was accumulating in region and actually much more so in both Europe and in North America than what was happening in the Asia region. Now, of course, over time, that's going to be an enormous problem, and it currently is as well. But for us, it was really about making sure that we were able to execute on an industrialization path and scale. And in doing so, what we did was we essentially looked at all of the available opportunities that sat in Europe and in North America. And in North America specifically, we looked at about 30 different sites. And when you look at this, you need to have a couple of different things play into this. One is population. So where do you have the waste sitting, which is really important? How are you able to organize the waste? Because ultimately what we're talking about here is really building the infrastructure of the future, right? You have to ensure that this pipeline of textile waste, post-consumer textile waste, is organized in such a way that it can feed into one of these very large units that we're building. So that's one thing. The second thing is industrial park. You know, you need to be able to tap into and plug into the chemistry that you need. And it's not just about the chemical aspect of things, it's also about power and infrastructure, rail, water, how are you going to transport things? And guess what? In Rochester, you have the largest industrial park in North America, the Eastman Industrial Park, which is the legacy of the Eastman Kodak Company, which is a 1,200 acre massive area that has been regenerated, you could say, to some extent. A lot of the old buildings have been taken down and really is now prepared for the future. So for us, the combination of population, waste, ability to build, scale, was all coming together for us in Rochester.
Okay. So you're looking at regenerating the equivalent of 300 million garment per year. Put that into perspective for us. What does that kind of scale actually means for North America's massive waste mounting?
Yeah, it's interesting. When you look at it that way, right? It feels like, oh my Lord, that's a lot of stuff, right? Yes. And it certainly is a lot of stuff. But taken into the context of what we currently generate in terms of textile fiber every year and the waste that comes with it at the end of life, it is actually rather small. But it's a beginning. For us, we were very clear at the Technip Energies Capital Markets Day in 2024, in the fall of 2024, when we said that we were going to industrialize this by building these regeneration hubs across both Europe and North America over the next decades. And we believe that by 2035, we would be able to regenerate approximately 700 to 800, kilotons or make polyester, which would then indicate that we would be dealing more with something like 3 billion garments at that point in time. So, to give you the perspective of this, you will be making approximately 38 to 39 kilotons of polyester out of all of those 300 million garments that we'll be processing. Now that sounds like a lot, 39,000 tons, but the reality is, in the grand scheme of things, when we make close to now around 75, 80 million tons, right, of polyester every year, it is a very small part. But it is a beginning. And I think that is important to point out here. It is a beginning because it's not just the beginning of regenerating, this textile to the polyester. It's also a beginning of building infrastructure, aggregation, sorting, preparation of this waste for the future. And I think that's the biggest, let's say, topic that we often have to educate on, is the fact that it isn't just about, okay, I gotta, regenerate all of these garments. It is how you actually facilitate that and build also the infrastructure, or help build in our case, and facilitate that. And that's one of the reasons we're in Rochester specifically teamed up with Goodwill, for example, right?
Right. So what is the market size like? As in, if I talk about the market potential in next 5 years, what numbers are we looking at?
Yeah, it's a great question, and I'll give you some stats here too to kind of frame it up a little bit. Today, about 12% of all textile polyester fiber that's made is made from recycled bottles. So the industry already is using about 8 million tons of recycled polyester from bottles, approximately. You know, it's a number that's growing, and polyester by itself is actually the one material that continues to grow the most in terms of what's being made into fibers. So if you just take the actual recycled polyester coming from bottles and you forget about all the virgin polyester that we're currently making, some of that is going to have to be replaced. It's not sustainable for us to use bottles as a source to make textile fiber indefinitely, right? Because the market is growing. So if you think about that, you could say that, well, to begin with, you know, some of that 8 million tons need to be replaced. You know, it's just, you know, market dynamics. And if you think about that, and you think about, you know, one little plant in Rochester making 39,000 tons, you can imagine the potential. So we believe that in 10 years, the market will grow for textile-to-textile recycling to be closer to 11 million tons in terms of potential. And we, like I said before here, expect to be making 700,000 to 800,000 tons then. Actually, if you looked at every player that's currently in the market trying to do what we do, the total combined volumes that all of those players would be able to make would be somewhere around 7 to 8 million tons if everybody built everything that they said that they would build. So you're not even getting into close to the potential, right? So that's the way to think about it.
Right. Understood. Yeah. Great. Yes. So, talking about the you know, technology, your tech is co-developed with Technip Energies and IBM Research. So, in a market full of green promises, what makes your molecular approach genuinely different from the rest?
Yeah, I think first of all, I think the promise of what we do is the fact that we're dealing with known chemistry. So we're not inventing the chemistry as we go along. It's known chemistry. The difference, and one of the only reasons that Technip Energies has decided to invest so heavily into this area, is because of our knowledge about polymers in general. So, you know, Technip is actually one of the leading technology companies in polymerization. So we have our technologies for Technip Energies that has been integrated in the build of about 1,000 polyester factories. So about a third of all of the volume that is made today in terms of polyester is made with our technology integrated somehow. So when Technip looked around the world and looked for a technology to help with depolymerization, which is essentially what we're doing here, you said it, the molecule, right? We break the chain of the polymer and we break it down into the monomer, and then we build it back up again. The missing piece for Technip was to have the best possible depolymerization technology. And of course, we have a very large chemical engineering department that looked across the world, and that company inside of Technip Energies is called Technip Energies Simmer. Simmer, that company, has over 75 years of polyester knowledge. It started in 1956, was one of the originators for taking polyester into technical fibers, and the knowledge that sits in there is very extensive. So we looked and scouted, you know, globally for the best technology, and found the IBM technology that was under development at the time. This is back in 2018, 2019. Now, what was Technip looking for? Three things. What technology could do what it needed to do as fast as possible, because you were going to deal with a lot of product, right? We talked about the 300 million garments. That's a lot. Number two, you needed to be able to do that using as little energy as possible, so as efficient as possible in terms of you know, being effective. And then third is yield. You know, at the end of the process, what is your yield once you have depolymerized? You know, how efficient are you? And what they found was that the combination of the glycolysis foundational process that we have, together with the catalyst that we're using, showed the most promise of being able to deliver on those three things. What we've proved out since then, and we actually did move all of the research and development from IBM in Al Madina in 2021 to Germany, to Frankfurt, where we've also built our 1,000-ton demo plant, which was completed in 2024. Okay. Of course, since then, we have greatly expanded on the core technology, and we have now added a number of steps to make sure that we can handle the problem. And the problem is 6,000 different chemicals from 300 million, like you just said, garments coming in. And that's part of the unique thing that we can do with this technology and the extended technology that we now have, which is to take post-consumer textile waste that is mixed chemistry, mixed materials, and actually do that at scale. And that is the absolute key and the essence of trying to solve the problem of post-consumer textile waste is your ability to take the mix. And today, we're very focused on doing that with about a 70-30 mix of polyester and cotton, because that is what you would normally see if you looked at the average. And if you can take the average, as you understand, you would be able to do this also most efficiently at scale. Okay. So for us, that's what makes it unique, right? Is our ability to do it fast, with high efficiency, and with great yield. So as a consequence, our process is about, is 50% lower in terms of carbon emissions versus if you were doing this, taking virgin PET out of the ground. Mm-hmm. And because we're breaking down the molecule, right, we can do it over and over and over again in an infinite loop, if you like, which means that every time you do it, if you were to recycle a garment over and over and over again, you'll get that 50% gain every time.
Oh, that's interesting.
Yeah.
So let's talk about circularity. Everyone talks about circular fashion, but very few actually deliver it at scale. What are the hardest boots on the ground roadblocks you faced, and how is Reju clearing them?
Yeah, I think the let's say the barrier to entry into circularity is of course a big challenge for the industry, and why so? Well, if you think about where the gap is, where is the gap? Well, right now the gap is from the moment a garment becomes waste until whatever that garment has to go through in terms of being aggregated, being sorted, being prepared for recycling or regeneration, then regenerated, and then repolymerized, and then spun back into yarn and fabric. That entire gap is not connected today. So, you need to build the upstream infrastructure of aggregation, sorting, and preparation. You need to have the technology to be able to take what you have collected and actually turn it back into something valuable. And you then need to be able to reintroduce it back into the supply chain of the brands. That's not been possible before. It hasn't been possible, and it isn't that you don't have a lot of different technologies that can do parts of the process, but to do it all, to actually connect all of the dots. That's what we've been working on for 3 years, and our work is not complete yet, right? But we see a future where, as we connect all of the dots, as we're able to regenerate high-grade polyester back into the supply chain of the brands, the brands also have an opportunity, or the retailers, and that opportunity is to think about a resilient industry going forward. So now that you have an opportunity to do this in market, is there also an opportunity then to address the other problem that is being created by the industry, which is overproduction? You mentioned it yourself, overproduction, the creation of all of this waste. Part of it is because we just simply make too much. 20 to 40% of all textiles that's being sold on the market today is being sold at a discount. Some have that as their business model, but many would prefer not to discount as much as they do today. But a lot of it is just simply because we make too much. And why is that? Well, our lead times are long and actually getting longer. And there's no system in the world that will be able to, no planning and forecasting system in the world that would be, that could predict an absolute, right, in terms of making sure that you wouldn't overproduce. So to minimize that risk, to build a more resilient industry, we believe the opportunity is to also look at nearshore and reshore. And this is not about telling the industry to move everything from where it's being manufactured today. It is about taking this specific high performance, high grade product and start to also look at your business modeling. Can you nearshore, reshore, lower your inventories, create a higher turn, and ultimately discount less and actually have a more profitable model? What a novel idea. Actually make this a way to make more money. How would that be? You know what I mean? It's like it's an opportunity to not just force the upstream to evolve into a new system, but to actually look at your business modeling and say, you know what, I'm going to make some of what I do more in a nearshore, reshore model that's more circular, and at the same time drive down my inventories and get better cash flows. I mean, for me, that's always been the case. And by the way, if you look at the companies that I've managed through my career, and especially, if I look at the last one, Under Armour, we had about 50% of our sourcing in Asia, 20 to 25% in the Euromed, and the rest in the Americas. So, when people tell me it's not possible, I say, is it easy? No, because you have to change and you have to actually do that, which means that you have to actually sometimes maybe relearn how to do it yourself, so to speak. And that, of course, is something that's hard to do, but the reality is we all have to change. And I think this is an opportunity to drive a better business model going forward, and a more resilient one too. So, and I'm very optimistic. I see a lot of the brands and retailers that we're talking to and working with are also very well aware of this and are trying to do their very best to get there.
So I understand that. Correct me if I'm wrong. You are talking about sustainable practices.
Yes.
Yes. So sustainability is great, Patrik, but if the shirt falls apart, it's a fail. What performance advantages like durability or color retention are actually winning over the skeptics?
Yeah, it's a great question. It's funny, one of the opportunities, and I didn't realize this at first, so this is actually something that we've learned along the way, but it was, I guess, when we went into this, and the reason I was excited about this was, of course, to try to help the industry move to the next phase, right? To come to terms with, what we call the elephant in the room, which is really this very large problem that has been created with nobody being accountable. And at the time, just simply getting from the waste to the polyester, for me, was something incredible. What we have seen, though, is that the ability to be consistent in terms of the quality that we make, because remember what I told you, the Technip Energies Simmer company is an expert in repolymerization. And
right.
All of the technologies you have today on the market, whether it's hydrolysis, methanolysis, glycolysis, with or with catalyst, whatever, everybody, as they break it down, is going to get to either PTA, MEG, or into a BHET monomer at the end. That has to be repolymerized. Okay. Because we know how to do that, how to repolymerize. The combination of our ability to take post-consumer textile waste, the most difficult product, and break it down, and then take what's broken down and build it back up again, and an ability to make the best quality polyester gives us also an opportunity to deliver against something that normally in the industry has not been a factor. And why not? Well, remember what I told you, our technology sits in about 1,000 polyester factories. I know that there's no such thing as virgin polyester. What the heck is that? Okay. The only thing that is the fact that you're beginning with oil. The quality will be very different across the landscape, depending on who's actually made the polyester originally. And there is such a thing as better or worse polyester in terms of quality when you want to make textile yarns out of it. So here we have an opportunity, and you talked about sustainability. Of course, we want to make sure that We're also working downstream to make sure that we make the best possible quality of polyester, to make the best possible yarns and fabrics, to make the journey for that garment, home textile, for whatever it is that's being made, the best possible until we get it back and regenerate it again, right? So that's part of what we're doing as well.
Right. The fact that Reju polyester, can be recycled multiple times, it's a great game changer, right?
Yes, It is. It is a game changer, and I think if you also then take into consideration that your carbon footprint will be about 50% less every time you do it. This is, the future for me. We have to start thinking about our raw materials. And, here at Reju, we have a very clear purpose to unlock infinite possibilities within finite materials. That's why we go to work every day. And if you think about the finite material here being oil, we can all debate, right? We can all have a conversation about, well, how much is there left? And I don't know. I don't think you know. I don't think anybody knows exactly how much is left. But we can agree on one thing, I think. That is the fact that it's finite. And in this very volatile world that we live in today, where raw materials has become something very important, I think the realization of the term finite is very much right front and center, whether it's oil or anything else. Polyester is oil. So from a sovereignty perspective, and from a resilience perspective, if you're a very large global brand, do you not want to actually make sure that you are diversifying how you get access to raw materials to make your product? If I were a CEO for a very big company today, this would be one of my very first priorities, right? Because without that, I'm not going to be in business. So I think that we're entering into a whole new era. It hasn't hit home fully yet, but it will for sure.
You're getting there, yes. Nearshoring and supply chain resilience are the buzzwords of the year.
Yep.
How does Reju helps brands navigate the chaos of geopolitical uncertainty and supplier disruptions?
Yeah. So I think as you think about the downstream, once we have made our product into polyester, we have of course the opportunity to easily move that around. When it's actually textiles before it comes to us, it's difficult to move around. A lot of volume, a lot of weight, and once it's made into polyester, very easy to move around. Now, one of the opportunities that we see is the fact that there is an industry that still exists, both in Europe and in the Americas, for making yarns and fabric and also making garments. And is it as big as what you find in APAC? No, it's not. But what do you really need to do here? And we come back to the volumes again. So if you think about what I've been talking about, which is 700 to 800,000 tons in 10 years, if you think about how much a large retailer in the United States, that's not even global, maybe regional, would need a year, you would be shocked. Because we know that those volumes are in the hundreds of thousands of tons. So now you start to ask yourself, well, actually, if you then split that 50-50 and the 700,000-800,000, and you say half is in Europe and half is in the US, would that be possible to produce into garments regionally? Absolutely. And that would also then potentially create a resilient industry regionally. And you start to think about that, right? And you start to think about what we actually make out of polyester. And you start to realize that it's actually kind of essential that we do keep some resilient industry going in textiles, because it isn't just the stuff that you and I wear every day that we make. We also make uniforms. We also make, car tires. We also make furniture, medical equipment. I mean, there's quite a lot of stuff that needs to get made and should probably be made regionally going forward. And I'm talking about all three regions now, not just Europe and North America. So For us, it is also a quest, if you like, to facilitate this ability to build a more resilient industry. That's our role, we see. So working downstream with spinners and yarn manufacturers and makers in region is also one of the things that we do.
Okay. Right. So you have got Hub Zero in Frankfurt and a site in Netherlands.
Yeah.
What's the biggest lesson learned in Europe that you're now importing to US strategy?
Yeah, so actually we also announced last week France, right? So we have 3 now. Luck in France was also announced last week. So we have exactly. So we have 3. So what we learned, in this process, a couple of different things. I think first of all, again, I come back to it, but how we think about the infrastructure build upstream is critical in any one of these areas. The reason we picked Camelot was in the same way that we picked Rochester, important because of first of all, the Dutch intent of building a circular economy by 2050. And the entire country is going circular. The Camelot site is a circular effort in itself, but the Netherlands is also one of the big aggregators of post-consumer textile waste in Europe. So very, very natural fit for us to do that. Luck in France, which is in the southwestern part of France, again plays into a geographical facilitation as it relates to aggregation of waste, capturing both France and Spain. But also, again, the site in Luck is a perfect chemical site for us to be operating out of. Easy access with train and rail. All of the facilities as it relates to energy and other infrastructure that we need, and a very forthcoming and good partner in the region. And Rochester was the same. So the learning that we have is accumulating, right? We're starting to understand how to think about the feedstock and the infrastructure of the future. To give you a sense of the scale of things for us, we have worked with over 135 different companies in Europe over the last 3 years to get the pipeline of infrastructure ready. In the US, we're working with both Waste Management and with Goodwill and many others to make sure that we're preparing for the future, because that is key, right? I mean, we cannot operate one of these regeneration hubs without having absolute certainty as it relates to the infrastructure. Think about it, right? So we're replacing, let's say, the oil pipeline, right, with a different type of pipeline. And when you open a 50,000 ton regeneration hub, you need to be very sure that there's going to be a number of lorries coming in every day, feeding that. So and for the next, I would say from now on as well, as you go into the future here over the next couple of years, that build will continue, because it isn't just the investment that we're making into building one of these very large units. It's also the investment that needs to happen upstream. You need to actually automatize some of that sorting. Today, 99% of all the sorting that happens for apparel, for example, textiles in the world is done manually.
Okay.
You can't do that manually if you're going to feed a number of these very large regeneration hubs. You need to automatize all of that. You need to be able to sort it. And we also need to sort it because we want to create maximum value upstream, right? So we want to make sure that if it's 100% cotton, we want to make sure that goes to the cotton recyclers, right?
Exactly.
If it's nylon, we want it to go to the nylon recyclers. And that's of course the other thing that we do, because we're a chemical engineering company, is we're making sure that we're not just addressing the polyester. Because as we do our regeneration, we also get elastin, we get dye, we get cotton recycling, all of those things going forward. We also see opportunity in regenerating.
Right. So let's talk about some of the technical benchmarks. Reju PET isn't just another recycled option. It's a true virgin alternative, as you said. So what technical benchmarks did you have to hit to prove to the world that this stuff is real deal?
Yeah, that's actually, thank you for that question, because that is not something that's maybe so often asked. And I think, again here, remember, we've been making polyester for 75 years. So for us, understanding what good looks like is very clear. What has not been done so much before at scale is dealing with RBHET. So the BHET, which is the monomer that comes before polyester, which is the last monomer step actually before you get into polyester. And the reason for that is because when you normally build a polyester factory and you take virgin oil and then make it, refine it into and put it into a polyester factory stream, you're going to go through a number of chemical steps, PTA, MEG, then BHET, and then into polyester. And you never segregate the steps. So BHET is only a transitional stage in a normal chemical flow. So the reality is the way to think about what comes out of Regeneration Hub Zero or a future plant in terms of the BHET aspect, that gives you actually another opportunity, because nobody has ever purified BHET before. So what happens if you actually have a cleaner beginning, let's say, before you make the polyester? So it isn't just about the polyester, right, quality. We have also had to pay attention to benchmarking, if you like, a new world where actually BHET becomes a product.
Okay.
And so for us, that's some very novel thinking and novel work that we've been doing there. And I think now we are absolutely at a stage where we understand what we can do in both those aspects. And that's why I'm so excited, is because the quality of polyester that we will be putting out, the benchmark of where that sits. The difference is when you come to Reju and you buy Reju polyester, you will know exactly what you get every time, because we can make it to spec. And I think that is a key. All of our customers will know that if you begin with Reju polyester, you're going to end up in a good place, because it's going to be consistently at a very high quality. So gives you a lot of opportunity to make great product.
Right. Patrik, battle for polymers is rising, The packaging sector is aggressively hunting for the same polymers you use. How does that competition impact your pricing and long-term competitiveness?
It's a very, very good question. I think across the board, you're absolutely right. The fight for the polymer molecule here is and overcapacity is right. I mean, there's like way too much capacity, and capacity continues to be built out. I think one of the questions that we always ask ourselves is affordability. Affordability is always, even if you have highest quality, there's an affordability question there too. So what I would like to do is, very often when this question comes up, I'd like to reframe it. Affordable compared to what? Now, if you're looking at affordability compared to virgin, then the context is wrong. Why is the context wrong? Because with virgin, it's a different product. What we're trying to do is we're trying to solve the outcome of an old linear system, which is a tremendous amount of waste. Not just waste in terms of actual waste. In other words, today 85 to 87% of all textile goes into the ground or is being burned. Burning a finite resource in this day and age, I think, is not so smart. Let's just say that. Putting it into the ground is also not so smart. And I think there's a reckoning of what actually happens to this when it sits in the ground in terms of leakage and other things that is going to come around to haunt us. But that's a separate discussion. So ultimately, if you now say, okay, well, I'm going to actually not make this into waste, I'm going to valorize this waste. I'm going to put it into a new loop, a circular loop, and I'm going to make it into something that I can use again. The question you have to ask yourself is, are you the most affordable alternative in that cycle?
Exactly.
And in terms of that, I'm 100% clear and certain that we are the most affordable alternative. And we're the only alternative that can scale. So we're the only player today that are doing this in the Western world. We're the only player that are focused on post-consumer textile waste, the biggest problem. We're the only one that is building in North America. So what are we trying to do here? Are we trying to actually solve the problem we're creating? Or are we simply trying to create another material? We're trying to solve the problem, and in doing so, actually doing it in the most affordable way possible, right? With a circular model where we're also weaning ourselves off the dependency of a finite resource extraction, strategy into a new type of strategy that's much more resilient and will be demanded in the future and necessary in the future. And how great is that? You're solving this massive problem that today is creating absolutely zero value into something that can be valorized for future generations.
Right. So, Patrik, can regenerated materials actually reduce the long-term price volatility we see in conventional fibers like nylon over the next 12 to 24 months?
Well, I think nylon is a good conversation too, because I think it's similar to polyester. I mean, we would welcome entrance into that space too, because it would help us. But the ability to do with nylon what you're doing with polyester is similar, right? It's a molecule, and you do it in very similar ways as it relates to depolymerization and the difference is that nylon is a smaller fiber in terms of volumes in the world, and also has a more narrow application, ability. So I think for us, it is going to be something we will focus on going forward, but it isn't our number one priority. Our number one priority is polyester, and our secondary priority is cotton, because that is the second largest fiber group, and then we're going to get to nylon. We're also dealing with elastin, by the way, as we're talking about fibers, and there we're already making progress in terms of working with the elastin producers to make sure that we're able to feed what we get out of our process in terms of elastin into their process to be able to regenerate elastin as well. Similar with dyes, we're also working on the dye track to make sure that we're addressing an opportunity to recycle dyes. So, Reju is so much more than Reju polyester going forward, but we have to make sure that we don't get distracted. We have to solve the biggest problem first. It's about prioritization. And right now, with polyester being 60% of all fibers made in the world, with the aggregation of waste accelerating, we got to get on with it.
Does make a lot of sense, yes. So finally, Patrik, if we fast forward 10 years, how has Reju transformed the way a teenager in New York or a designer in Milan thinks about the clothes they wear and discard?
Yeah. So if I look forward, 10 years from now, first of all, I think we have enabled circularity. And I think that is key. We have shown a model that can work. I think that in itself will give hope to the two persons you just spoke about. Because it shows that the realm of the possible, if you like, and it will be an ignition, I think, into thinking more holistically about the life cycle of things. And in the textile industry, it's sorely needed. We have lived in a linear model that we have perfected. I've been part of that, perfected over 100 years, right? That is no longer, sustainable in the long run. So my hope is that we will be able to, at that point in time, we will have shown that this is possible at scale, and that it works, and that the model works. And I think when you say the model here, when I say the model, it's really important to understand that we are truly thinking about systemic change here. And one of the important things in that systemic change, in that circular model, is that everybody wins. And when I say everybody wins, it has to be an economically viable model, because if it's not going to be sustainable by definition. So we are very, very focused on making sure that it's affordable, but also economically viable as a system going forward. And I hope that when we fast forward 10 years into the future and we have that designer or that young person shopping something, that they have a sense of what could be in their lifetime going forward. And by that time, maybe I won't be here, doing this job necessarily, but I'm also very encouraged by the fact that I just saw that Warren Buffett retired at 93, which would essentially put me at midpoint in my career. So maybe I am. Who knows?
Yeah. So, Patrik, it's rare to talk to someone who is literally weaving the future of the industry. From the molecular level at IBM to the industrial hubs in Rochester, LAC, Reju is proving that waste is just a failure of imaginations. Thank you for joining us and giving us a masterclass in circularity.
Thank you very much. Pleasure to be here. Thank you.